Raw data is chaotic. It rarely arrives perfectly formatted for analysis. Before you can extract any real insights, you have to organize that noise into a strict, readable structure. To see how this organization process works, we will use one of R's built-in collections, the Iris dataset, which contains 150 individual measurements of different flower species. To tame this information, we use a specific package called the Tidyverse. It provides a dedicated set of commands, often called verbs, that handle the heavy lifting of data manipulation. Mastering these core verbs is your starting point. Sorting, filtering, and reshaping your data ensures that your charts and models are built on a consistent, well-defined foundation. Setting up your environment is straightforward. In your RStudio script editor, run the command library tidyverse to load the complete toolset. The engine driving this workflow is the pipe operator, written as a %sign, greater than sign, and another %sign. Think of the pipe as meaning and then. It passes data into an action, moving the result to the next step. Be precise. If you type spaces between characters, R throws an error. The symbols must be typed continuously. Now we want to narrow down our rows. The filter verb lets us extract only the data where the species is Virginica. Keep in mind, R requires a double equal sign here to check for that exact match. If you need to isolate data based purely on position, you can use the slice verb. This command extracts a specific numerical range of rows, like selecting rows 45 through 55. This subsetting removes irrelevant noise right at the start. By stripping away what you don't need, you focus computational power on what actually matters. Once you have isolated the right data, you often need to modify its internal structure so it is easier to read and work with. We can clean up our column titles using the rename verb. For example, changing the default label, sepal.length, to a more standardized format like seplin. You can also generate entirely new data points using the mutate verb. Here, we want to find the ratio between the length and the width. Dividing sepal length by sepal width generates a brand new ratio column. But R is strictly case-sensitive. Running this calculation with a lowercase l or w instead of capitals causes the code to immediately break. Standardizing labels and calculating new ratios generates specific metrics unavailable in the original table, making the data highly useful for your research goals. With our structure organized, the final step is data aggregation. This is the process of compressing hundreds of individual data points into high-level, interpretable summaries. To do this, we use the group by verb. This command logically partitions the entire dataset into distinct categories based on the flower species column. Next, the summarize verb acts upon those groupings to calculate a single metric, like the mean sepal length, for each species. Finally, the arrange verb sorts the resulting data in descending order, placing the highest values clearly at the top. This approach streamlines your workflow. Stacking group by, summarize, and arrange through the pipe executes a multi-step analysis in a single, readable block of code. Looking back at our final script, we have built a tight sequence of commands. The raw iris data flows sequentially through our verbs, getting filtered, mutated, and summarized step by step. What started as a chaotic collection of 150 different measurements has been compressed down into a clean, perfectly ordered 3-row summary table directly in your console. This exact workflow is universally applicable. You can take this same sequence of verbs and apply it to other built-in collections, like the MT cars or Beaver1 datasets, to achieve the exact same level of organization. Writing efficient Tidyverse scripts allows you to move beyond manual sorting and create automated, repeatable workflows for any dataset.